Since the 1960s, scientists have suspected that frozen water could survive in permanently shadowed craters at the moon's poles. Both hydrogen and oxygen could be trapped within the lunar soil. So to find water on the moon, scientists are looking for indications of hydrogen using the Lunar Reconnaissance Orbiter's LEND neutron detector. By observing the interaction of neutrons with the lunar soil, scientists can interpret how much hydrogen is likely to be present. In order to make a detailed interpretation, however, LEND needs to observe a large number of neutrons. Because LRO is constantly moving, LEND is never over one place long enough to count many neutrons. So, to make a detailed interpretation of neutron flux, scientists add together many measurements from many orbits. With each orbit, LEND's dataset gets larger, and its picture of neutron flux continually improves over time. The dark blue regions in this visualization are places on the south pole of the moon with a suppressed flux of neutrons because of their interaction with hydrogen. These areas strongly suggest the presence of water frozen within the soil. While previous lunar missions have observed indications of hydrogen at the moon's south pole, the LEND measurements for the first time pinpoint where hydrogen, and thus water, is likely to exist. By combining years of LEND data, scientists see accumulating evidence that there is water on the moon. And as LRO continues to return data, our picture of the moon and its water will continue to get better in the years ahead.
NASA's Artemis missions will establish the first long-term human presence on the lunar surface. Living and working on the lunar surface will require using resources that are already present there, like water ice, which can be used for life support and fuel. The Polar Resources Ice Mining Experiment 1, or Prime 1, will be deployed to the lunar south pole by our commercial lunar lander partner, Intuitive Machines. Prime 1 is intended to drill for water on the lunar surface. Prime 1 is the combination of two instruments, a drill built by Honeybee Robotics called Chand, which stands for the Regolith Ice Drill for Exploring New Terrain, and the Mass Spectrometer Observing Lunar Operations, or MSOLO, which is a commercially available mass spectrometer from our industry partner Inficon that we have modified for operation in the harsh space environment. Trident will drill into the lunar surface, taking one small bite deeper into the soil at a time and bringing that sample up and depositing it on the lunar surface. MSOLO will then evaluate those samples as they arrive on the surface to identify and measure the composition of water and other volatiles emanating from the samples. The objective of Prime 1 is to inform NASA's plans for mining resources on the lunar surface, as well as mission operations for a future NASA lunar rover mission called Viper. So how will we extract water on the moon? The Prime 1 mission will set the foundation for future resource utilization on the moon, a key component for the success of upcoming Artemis missions, as well as expanding human exploration of our solar system.